Well, good day students, and welcome to the last video. This is going to be Circles 16, and today we're going to talk about equations of circles and really a more algebraic aspect of geometry. So when I say algebraic aspect of geometry, what am I really talking about? Well, what I'm saying is that any geometric shape you can actually describe on a coordinate system, as I have here, where I have the x-axis and the y-axis, the origin right there, and you can actually describe it on an x and y-axis. So what I want to do is we need to first describe how to get a radius, and I'll show you that here in just a second. Now, the one thing you can see in this diagram is we would like to find the length of the radius. And a radius is always equal, so no matter where I'm drawing the radius in this circle, every one of those are always equal. So what we want to do is we want to focus on those radii. Now, we want to focus on those radii. I've changed the picture a little, but here's the radius we want to find right there. The center is at a point x1, y1, and the point on the circle is x2, y2. So how are we going to find the radius? How are we going to find that length? Well, we can always do our old pal, the Pythagorean theorem. And once again, the Pythagorean theorem is going to help us do things that we couldn't do without it. And so it turns out that if I start to relabel this thing, this point on this axis is point x2, this one was x1 on the x-axis, this over here would be y1, the height for that point, and this over here would be y2. And so I can now find the length of those objects. This is going to be the bigger number, x2 minus x1. So the length is x2 minus x1. And in the Pythagorean theorem, we have to square that. And the length of this one right here is going to be y2 minus y1. And in a Pythagorean theorem, we have to square it and add those together. And those are going to equal the radius squared. And this is traditionally called the distance formula. But in our case, if we actually know the center of the circle, and instead of calling it x1, y1, or x2, y2, if that had been the center, we could actually change up this equation, and we could say, suppose the center is the point xy, and then the point on the circle is x1, y1, then this little distance formula, this Pythagorean theorem, would become x minus x1 squared plus y minus y1 squared equals the radius squared. And this, the Pythagorean theorem in another form, is actually the equation of a circle with centers x, y, and a radius r. And now we're going to rewrite that in a little bit, even a little bit more different form next time. But in general, all we're using is the Pythagorean theorem to write the equation of a circle. So, given everything we said, if we find the center of this circle, say it's right there, and we draw a radius, that radius will have length r, the center will have the points hk, and the point on the circle we'll just call some random xy. And when we put that all together as a Pythagorean theorem, right, if you were to label everything and do it, you would end up with the equation of a circle, and this is the formula you want to memorize. Or this would be, if I wrote anything else down, I would write this down. It would be x minus h squared plus y minus k squared equals r squared. Now, what we're going to do is we're going to use this to do examples. And so example 1 is, what if my center is a point 2, negative 3, and my radius is equal to 5? What would be the equation of the circle? Well, I would just write x minus the x value, 2, squared, plus y minus the y value, so y minus a negative 3 is y plus 3 squared, equals the radius squared, and 5 squared is 25. And this is the equation of a circle that fits this piece of information. So suppose you have a problem like x minus 3 squared plus y plus 2 squared equals 16. And they say, what's the center and what's the radius? Well, I always like to do the radius first. I think that's the easiest. If in the formula, the 16 should be r squared, so the radius is r squared equals 16. So r equals the square root of 16, or 4, and therefore the radius is equal to 4 units. What's the center? Well, the center just comes from these hk values, and all you have to do is essentially choose the opposite sign. So if I have x minus 3, then that means 3 is the x value of the center. And if I have y plus 2, that means negative 2 is the y value of the center. So that's how you find a center and radius. So our next problem is, we want to write the equation, of the circle when the center is at negative 5, 3, but the circle passes through 2, 1. So visually, what is that? Well, if you had a coordinate system, you'd be at negative 5, 3, that's where the center is, and 2, 1 would be here. So this would be your radius, and the circle would start to look like something like that. Alright? And so the trick is, we need to find the radius to write the equation. And why is that? Well, we already know the equation is x minus h squared plus y minus k squared equals r squared. And we already know h and k right here, so that's x plus 5 squared plus y minus 3 squared equals r squared. So if I knew the radius, then I'd be okay. So all I need to do is look at this diagram, and what I see is the radius is the distance between this point and this point. Well, I can cheat and use my old friend, the Pythagorean theorem. And so the question I have is, how long is this? Well, I got 2 over here and then 5, so I know its length is 7. And then how long is this piece right here? Well, I'm going from 1 up to 3, so I know its length is 2. So I can set up the Pythagorean theorem. 2 squared plus 7 squared equals radius squared. And that's 4 plus 49 equals r squared. So 53 equals r squared. And then you take the square root. So the square root of 53 is equal to our radius, but also we know 53 is equal to r squared. So to finish my problem, I just write x plus 5 squared plus y minus 3 squared equals 53, the radius squared. And that's all for this video, and this is the last video in Chapter 10.